Bismillahirrahmanirrahim. Today we will talk about the chapter 7, polynomial equations. Previously we have talked about complex numbers in the last chapter. Now we will talk about the polynomial equations. So let's start. We know that expressions like x square minus 3x or minus 7 x power 102 minus plus 3 minus iota x power 17 minus 7 or more generally something like p of x is a n x power n plus a n minus 1 x power n minus 1 plus a1 x plus a naught, where the coefficients a naught, a1 to an are complex numbers are called polynomial in x. A polynomial equation is of the form is an equation of the form p of x is 0, where p of x is a polynomial. The degree of such an equation is the highest power of x that appears with a non-zero coefficient. Right? For example, equation of degrees 1 take the form ax plus b is 0, where a is non-zero. These are also linear equations. Equations of degrees 2 take the form ax square plus bx plus c 0, where a is non-zero. Are quadratic equations. Equations of degree 3 are cubic equations of degrees 4 or quadric equations of degrees 5 or quintic equations, and so on. Okay. Complex number alpha is said to be a root of the polynomial if, so name it root, a complex number alpha and c is said to be a root of a polynomial equation p of x is 0 if p of alpha is 0. The search for formulae for the roots of polynomial equations was one of the driving forces in mathematics from the time of the Greeks until the 19th century. Let us now taste a tiny flavor of this huge subject in the hope that peptides are waited for more. Now, it is obvious that any linear equation ax plus b is 0 has one root, namely minus b over a, and then any quadratic equation ax square bx plus c is 0 has two roots, namely not minus 1 over 2a minus b plus minus the root b square minus 4ac. Okay. Now, things are less clear for cubic equations. We don't have something like this formula. Now, indeed, while the formula for the roots of quadratic was known to the Greeks, it was not until the 16th century that the method for finding the roots of a cubic was found by the Italian mathematician Scipio Ferriero. In 16th century, a method was found for the roots of a cubic equation by Italian mathematicians. Scipio Ferriero, Tartaglia, and Cardan. And here is their method. So we will mainly talk about in this one as the solution to the cubic equation. Solution to cubic equations. We have an equation. Consider the cubic equation ax cubed plus x cubed plus a x square plus bx plus c 0. We are considering that the coefficient of x cubed is 1. The first step is to get rid of the form of the x square term. This is equation star, or like 7.1. The step 1 is to get rid of x square term. This is easily done. Put y is x plus a over 3, then y cube is nothing but x plus a over 3 cube, which is x cube plus ax square plus a over 3x plus a cube over 27. So equation 7.1 becomes y cube plus p prime y plus c prime is 0 for some b prime c prime. Write this equation. Write this equation is y cube plus 3h y plus k is 0. This is equation 7.2. The coefficients 3h and k can easily be worked out given ABC. Here comes the clever part. Write y is u plus v, then y cube is u plus v cube, which is u cube plus v cube plus 3u square v plus 3u v square. And you can write this as u cube plus v cube plus 3uv into u plus v. And this can be written as u cube plus v cube plus 3uvy. Hence the cubic equation. Hence the cubic equation is going to be y cube minus 3uvy minus u cube plus v cube is 0. And this is equation 7.3. And has a root, has u plus v a root, as a root. Now this is interesting. Now, our aim now is to find u and v so that the coefficients in equation 7.2 and 7.3 are matched up. So find u and v. Okay. To match the coefficients, we require to match the coefficients. What we can write, h is minus u into v, k is minus u cube plus v cube. This is 7.4. From the first of these equations, we have from the first of these equations, we have v cube is minus h cube over u cube. Hence, the second equation gives, hence the second equation gives u cube minus h cube v cube is minus k. So u power 6 plus k q cube minus h cube is 0. And this we write 7.5. This is just a quadratic equation for u cube, and a solution is. Now this is 7.5 is just a quadratic equation for u cube, because as we can write this as u square power 3 u cube square plus k u cube minus h cube is 0. Then we have u cube is 1/2 minus k plus the root k square plus 4 h cube, because b is k, a is 1, c is minus h cube. So you can put this. Then from 7.4, you can write v cube is minus k minus u cube, which is nothing but 1/2 minus k minus k square under root k square plus 4 h cube. Now is y was u plus v. We have obtained a formula for the roots of the cubic. we have now the formula for the roots of cubic equation 7.2. And that formula is third root of 1/2 minus k plus under root k square plus 4h cube plus third root of 1/2 minus k minus under root k square plus 4h cube. Now, since a complex number has 3 cube roots, complex cube root, and there are 2 cube roots to be chosen, it seems that there are 9 possible values for this formula. However, the equation uv is equals to h implies that there are 9 possible values for this formula in C. However, uv is minus h implies v is minus h over u, and hence there are only 3 roots of 7.2, and hence there are only 3 roots of 7.2, these being u minus h over v, these being u minus h over v, u minus h over u for each of the 3 choices for u. For each of the 3 choices for u. Specifically, if u is one of the cube roots of this, specifically, if u is one of the cube roots of 1/2 minus k plus the root k square plus 4h cube. The other cube roots are the other cube roots are u omega plus u omega comma u omega square. Omega is e power I theta 2 pi I over 3. So the roots of the cubic equation 7.2 are, so the roots of cubic equation 7.2 are u minus h over u omega u omega minus h omega square over u omega square minus h omega over u. Once we know the roots of 7.2, we can, of course, write the write down the roots of general cubic 7.1. Since x is y minus a over 3, now then by 7.2 we can write roots of 7.1 since x is y minus a over 3. We'll talk about the examples in the next part.